Beneath the ocean's surface exists a world humanity was never meant to witness. A hidden realm where sunlight vanishes and life reshapes itself into forms that feel almost impossible. As we descend, we pass through invisible boundaries, the sunlit zone, then the twilight zone, and finally the midnight depths. With every meter downward, the creatures we encounter become more alien, more extreme, more unfamiliar. We've sent robotic explorers to Mars, we've charted galaxies billions of light years away, yet the deep ocean remains one of Earth's greatest mysteries. Less than 5% of it has ever been explored. In fact, we know more about the surface of the moon than we do about what exists 6,000 feet beneath our own seas. At the surface, the ocean is alive with light. Sunlight fuels vast blooms of plankton, which sustain fish, which in turn support entire food webs, from vibrant coral reefs to the largest whales on the planet. But descend beyond 200 meters, and the light begins to fade. We enter the twilight zone, a massive layer of ocean stretching nearly a kilometer deep. Here, sunlight is too weak to power photosynthesis. The plankton forests disappear. There are no plants, no green energy, only darkness. Life here survives on a slow, constant snowfall drifting down from above. Tiny particles of waste, decaying organisms, and microscopic remains sink through the water column. Scientists call this nutrient rain marine snow. To us, it seems insignificant. To the creatures of the twilight zone, it is everything. And where food exists, life follows, but not life as we know it. The animals of this realm have evolved into some of the strangest organisms on Earth. Many are nearly invisible, their bodies transparent like living glass. The glass squid drifts silently through the dark, a ghost in an ocean without light. Its organs are barely visible, a faint suggestion against the blue. The glass octopus is almost impossible to see, its eyes the only solid features that betray its presence. Why so many species here have evolved transparency remains a mystery. It may be camouflage, a way to vanish in the weakest traces of light, or it may be efficiency, an adaptation for a world where every pigment costs more energy than it returns. Others take the opposite path. Instead of disappearing, they create light. In the darkness, many creatures generate their own glow through a chemical reaction known as bioluminescence. To us, it appears magical, flashing points, glowing patterns, entire bodies pulsing like drifting lanterns. But in the twilight zone, light is not decoration, it is survival. Some species use it to lure prey, others to attract mates, and some use light to erase themselves entirely. This strategy is called counter-illumination. From below, predators can detect a dark silhouette against the faint glow filtering down from the surface. To defeat this, animals like the firefly squid line their undersides with light-producing organs. They precisely adjust the brightness to match the light above, canceling their shadow and dissolving into the background. It is camouflage by imitation, creating light in order to disappear into it. Other creatures play even stranger games. The bloody belly comb jelly glows deep red. At these depths, red light never penetrates, making the jelly appear pitch black. Inside its stomach, the glowing remains of bioluminescent prey are hidden, concealed from predators that would otherwise spot the telltale light. In a world shaped by light, or of the absence of it, every adaptation is a negotiation over visibility, who can be seen and who cannot. But the Twilight Zone is not only a realm of illusion, it is also the stage for one of the greatest events on Earth. Each night, as darkness spreads across the surface, billions of creatures rise from the depths. Lanternfish, squid, jellies, an entire living army ascends toward the surface to feed on plankton under the cover of night. At dawn, they retreat once more, sinking back into the gloom. This daily movement is called diel vertical migration. It is the largest synchronized migration on the planet, greater in scale than all herds, flocks, and swarms combined. And yet, for centuries, it went unnoticed. It wasn't until World War II that naval sonar operators detected a strange phenomenon, a false seabed that appeared each night and vanished each morning. It wasn't the ocean floor at all, it was life itself, an entire hidden world moving as one. The Twilight Zone is where the familiar rules of life begin to bend, where transparency becomes armor, where light is used to hide, where billions of animals rise and fall in rhythms older than humanity. This is the threshold of the deep, the first layer of a world we still struggle to understand. Beyond 1 kilometer, all sunlight disappears. We have entered the midnight zone, a realm stretching down to 4,000 meters. Here, there is no dawn and no dusk, only eternal night. Temperatures hover just above freezing. Pressure climbs to hundreds of times greater than at the surface. To human eyes, this seems like a place where nothing could survive. And yet, it is here that evolution becomes most inventive.
Consider the dragonfish. Unlike most deep-sea creatures, it can produce red bioluminescence. In the deep ocean, red light is effectively invisible, making the dragonfish's glow a private signal seen only by those equipped to perceive it. A living searchlight, it illuminates its prey without revealing itself. Even more astonishing, the dragonfish's eyes are specially tuned to detect this hidden color. It is as if the species has invented a private wavelength, one that only it can see. Other predators in the midnight zone perfect a different art: disappearance. Some fish are coated in ultra-black skin, so efficient at absorbing light that it reflects less than 0.5% of what strikes it. Even when a submarine's spotlight shines directly upon them, they seem to dissolve into the darkness. And then there are the anglerfish, among the strangest hunters ever to evolve. The female dangles a glowing lure before her jaws, a beacon in the void that draws in unsuspecting prey. But her greatest mystery lies not in hunting, but in reproduction. Males are born tiny, fragile, and nearly helpless. Their sole purpose is to find a female, an almost impossible task in an ocean of endless night. When one succeeds, he bites into her body using specialized jaws and fuses with her flesh. His organs gradually degenerate until he becomes little more than a reservoir of sperm, permanently attached and sustained by her bloodstream. It is one of the most extreme reproductive strategies known in the animal kingdom. Not every creature here is a hunter. Some are opportunists, scavengers, patiently waiting for food to fall from above. When a whale dies and sinks to these depths, it becomes an oasis in the darkness, sustaining entire communities for decades. And yet, even with modern submersibles, our knowledge of the midnight zone remains fragmented. For every species we have identified, scientists believe dozens more remain undiscovered. Each descent reveals animals never before seen by science. Creatures with glowing eyes, needle-like teeth, or bodies so delicate they disintegrate when brought to the surface. This is the midnight zone, a world where light is a weapon, where invisibility is survival, where even reproduction follows rules beyond human imagination.
4 kilometers below the surface, we leave the open water and touch the seafloor. This is the abyssal plain, one of the largest habitats on Earth, covering more than half of the planet's surface, and yet one of the least understood. There are no coral reefs here, no kelp forests, no towering landmarks, only a vast, silent desert of fine sediment stretching for thousands of kilometers in every direction. Temperatures rarely rise above 4 degrees Celsius. Food is scarce. Survival demands adaptations found nowhere else on Earth. One of those adaptations is size. Many abyssal animals are giants compared to their shallow water relatives. Giant isopods, the size of small dogs, roam the seabed. Amphipods, normally tiny crustaceans, can grow longer than a human hand. Even the elusive colossal squid, among the largest invertebrates ever to live, is believed to patrol these depths. Scientists call this phenomenon deep-sea gigantism, but its cause remains a mystery. Some theories suggest it conserves energy. Others propose it offers protection in an environment with few predators. The truth is, we still don't know. Life here also depends on rare gifts from above. When a whale's body sinks to the abyssal plain, it becomes a jackpot of nutrients. Within hours, scavengers arrive: sharks, hagfish, and swarms of amphipods. In time, stranger specialists take over. Bone-eating worms, known as osedacs, colonize the skeleton, extracting oils locked deep within the bones. An entire ecosystem forms around a single carcass, lasting for decades until nothing remains but dust. Other creatures survive on far humbler meals. The vampire squid, despite its fearsome name, is not a hunter at all. Instead of hunting, it gathers what the ocean provides. Using long, sticky filaments, it captures drifting particles of marine snow as they fall through the darkness. Even in oxygen-starved depths, the vampire squid thrives, powered by a blood pigment with the highest oxygen affinity of any known cephalopod. In this desert of silt and silence, life moves slowly. Creatures grow at a glacial pace, reproduce infrequently, and often live far longer than anything at the surface. The Greenland shark, which can descend into these depths, may live more than 400 years, the longest lifespan of any known vertebrate. Here, time itself seems to stretch, unfolding on a different scale. And yet, the abyss is far from empty. Every grain of sediment harbors countless microbes, quietly recycling nutrients and sustaining a vast, invisible food web that scientists are only beginning to understand. The abyssal plains remind us of Earth's true scale. They cover more area than all forests, grasslands, and deserts combined, yet remain largely unseen, unexplored, and unexplained. Beyond the abyssal plain lies an even deeper frontier. The ocean trenches, vast scars carved by tectonic forces, mark the boundaries where one massive plate of Earth's crust slides beneath another, dragging the seafloor down into unimaginable depths. This is the Hadal zone, named after Hades, the underworld. It begins at 6,000 meters and plunges to the deepest known point on the planet, nearly 11,000 meters below the surface. To put that distance into perspective, if Mount Everest were placed inside the Mariana Trench, its summit would still remain more than a mile underwater. Conditions here defy intuition. Temperatures hover near freezing. Pressure exceeds 1,000 times that at the surface. To a human body, survival would be impossible. And yet, life persists. Among the most astonishing inhabitants are the trench snailfish, fragile and gelatinous, with translucent skin and soft bodies. They appear far too delicate for such an extreme environment. Yet, they are the deepest living vertebrates ever discovered, thriving where no other fish can. Their secret lies in flexibility. They lack rigid bones, and their cells are reinforced with specialized molecules that allow proteins to function under crushing pressure. Other trench dwellers are smaller, but no less remarkable. Amphipods, shrimp-like crustaceans, swarm across the trench floor in vast numbers, feeding on whatever organic matter reaches these depths. But even here, in Earth's most remote environments, humanity has left its mark. Recent studies have found plastic fibers inside the bodies of trench amphipods, evidence that human waste has reached even the deepest corners of the planet. It is a sobering reminder that no place on Earth is truly untouched, a reminder that the deep ocean is not as isolated as we once believed. Along the walls of trenches, at hydrothermal vents, life takes an even stranger turn. Here, microbes draw energy not from sunlight or falling marine snow, but from chemicals erupting directly from Earth's crust: hydrogen sulfide, methane, even metals dissolved in superheated water. These microscopic organisms form the foundation of entire ecosystems. Giant tube worms, clams, crabs, and shrimp all depend on them. This is a food web powered by chemistry, not photosynthesis, proof that life can flourish in conditions utterly alien to the surface world. Discoveries like these force us to ask a larger question. If life can survive and adapt to such extremes on Earth, could it not exist elsewhere? Icy moons like Europa and Enceladus conceal vast oceans beneath their frozen shells, warmed not by sunlight but by internal heat. To study the Hadal zone is to glimpse what oceans beyond Earth might be like: dark, pressurized, and alive. And yet, despite its significance, the trenches remain almost unknown. Fewer people have visited the Mariana Trench than have walked on the moon. Each descent reveals species never before seen by science, from translucent sea cucumbers drifting like parachutes, to gelatinous forms with no clear anatomy, to microbes whose metabolisms defy explanation. For centuries, humans imagined the trenches as lifeless voids, silent graves beneath the sea. What we have discovered instead is resilience. Life that bends, reshapes, and reinvents itself to endure pressures beyond imagination. And still, the deep sea remains a world of questions. More than 80% of the ocean has never been explored. Every dive, every remotely operated vehicle expedition brings back organisms that challenge everything we think we know: transparent fish, glowing worms, jellies that break the rules of biology. Here, discovery is not rare, it is constant. Even among the species we recognize, the mysteries persist. Why do so many deep-sea animals grow to enormous sizes? The giant isopods, colossal squid, amphipods as long as a human hand. Why do others fade into near invisibility or cloak themselves in ultra-black skin that absorbs almost all light? And perhaps the greatest mystery of all is light itself. Nearly 3/4 of deep-sea creatures can produce bioluminescence. Some use it to hunt, others to hide, others still to communicate or survive. Yet we still do not understand how many of these complex chemical systems evolved, or why some species glow in colors no other animal can perceive. These are mysteries without answers, for now, and perhaps that is what gives them their power. They remind us that Earth is not fully known, that even on our own planet, vast worlds remain hidden in darkness. Worlds worth exploring, worlds worth understanding, and worlds worth protecting.